The last section we're going to look at here is probability. And probability is a way of assigning measures of uncertainty. We aren't guaranteed something is going to happen unless there is a 100% probability. So ways you could see probability written is a 30% chance of rain or 5 million to 1 odds. Something that's called a random experiment is anything where the results are uncertain. If you don't know what's going to happen, it's called a random experiment. Outcomes are the possible results of the experiment, so the way something can occur. It might be pulling out red buttons from a bottle. Sample space is the collection of all possible outcomes of the experiment. So that could be pulling out blue buttons, red buttons, green buttons. Maybe if there's an apple in there. It's anything that you can do with your experiment. And then an event is any subset of the sample space. So any result that you could have or anything that could occur from your experiment is considered an event. So an example that you see here is a coin being flipped and a dice being rolled at the same time. We want to know how many different outcomes are there for our sample space. Well, if we look at the coin being flipped, we can flip a 1 through, or the coin can be either heads or tails. And then the dice, we can either roll a 1 through 6. So first we look at what if I roll heads, or what if I flip heads? What are the different outcomes for the rolled dice? Well, I can roll a 1 through a 6. If I look at the tails, I can also roll a 1 through a 6. So I could have here a heads and a 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6. I could do the same thing with tails and a 1, tail 2, tail 3, tail 4, tail 5, tail 6. All of them. So if I list all those specific outcomes, that is the sample space. H1, which is heads and rolling a 1, H2, heads and rolling a 2. Multiplying all those things, I've got 12 outcomes. 2 options for the coin flip, 6 options for the rolling of dice. So there's your fundamental counting principle being thrown out there. 2 times 6, which is 12. What is the event of getting an even number? Well, the event is I want the even number. How many ways can that occur? Well, there's 6 different possibilities because I can either get a 2, 4, 6, and I get that with heads or tails. The final piece then is when the sample space is finite and the outcomes are equally likely, then the probability is taking the ways the event occurs and dividing by the sample space. So in other words, we want to find a percentage of what this event will occur. So when we look at that even number in the experiment, there were 6 out of 12, which was a 50%. 6 out of the 12 involved an even number, and there were 12 events total, so 50%. A couple of facts about probability. All events need to fall between or equal to 0 and 1. If the probability is 0, it's impossible that it'll occur, and if the probability is 1, it must occur. So let's do a couple of examples of a card deck. A single card is drawn from a standard deck of playing cards. What is the probability of drawing a king? Now there's a couple things you need to know about cards. First of all, we get 4 faces of cards, or 4 whatever of cards these are called. Diamonds, hearts, clubs, and spades. And then within those diamonds, hearts, clubs, and spades, you have an ace, you have the card 2, 3, 4, 5, 6, 7, 8, 9, 10. You have a jack, a queen, and a king. So for the diamond, there's 13 options. For the heart, there's 13 options. For the club, there's 13 options. And for the spade, there are 13 options. So what is the probability of drawing a king? Well, we've got a king of diamonds, the king of hearts, the king of clubs, and the king of spades. So we've got 4 out of 52. The reason there's 52 is if I were to list out the diamond, the heart, the club, and the spades, for each of those, as I said, we've got the ace, we've got cards 2 through 10, we've got the jack, queen, and king, which is going to be 13. 13 times 4 is 52. What is the probability of drawing a club? This clover is the thing that's the club. So we've got 13 different options of that because we've got an ace, the 2 through 10, the jack, the queen, the king of the clubs. So that's going to be 13 out of 52. And then what is the probability of not drawing a club? Well, if I know that 1 is where I have to draw the club, and then not drawing the club would be, there's the piece of the clubs that I do know. 1 is everything. Pulling out a club is 13 out of 52. Make a quick common denominator, 52 over 52 minus 13 over 52. So not drawing a club would be 39 out of 52. 2 6-sided dice are tossed. What is the probability that the total is 4? Well, if I look at that, I know my options will be, if I roll a 1 and a 3, I could roll a 3 and a 1, or I could roll a 2 and a 2. These dice are distinct from each other, so my sample space that I have is going to be 6 times 6, which is 36. 36 different options, 6 for the first die, 6 for the second die, and I can see right there, there's my 3 options out of 36. So 3 out of 36. And what's the probability that the total is less than 4? We'll do the same thought process. We know there's 36 options total. To get something less than 4, we've got 1 and 1, we've got 1 and 2, and we've got a 2 and 1, which would be 3 out of 36. Example 4, a committee of 3 is picked at random from a group of 4 boys and 5 girls. What is the probability that the committee will consist of entirely boys? Well, let's look at this from the event over the sample space setup. There is no order to this. There is no vice president, no chairman. All I want to have is this committee. And I've got to choose 3. So the event here is going to be entirely of boys. So if I've got 4 boys, I've got to choose 3 of them. So that's going to be my event. My sample space is then everything, and there's 9 people. So 9 choose 3. Which the percentage then is going to be 4 out of 84. The last piece then are just a couple of vocabulary words about probability. When various events happen in sample space, it is called the intersection if we have A and B. So intersection is A and B. And if this is event A, this is event B, the intersection is the overlap of the 2 events. The union of 2 events is saying the or, which is A or B. So if this is A, this is B. Or would be anything that appears within that Venn diagram. And then finally, the complement is everything that is not A. So everything that is not A, well, there's A. Everything that's not A is everything outside of this. So everything out here that is outside of A is considered to be the complement. And then finally, mutually exclusive events are 2 events that cannot occur at the same time, or 2 events from the same sample space that have no outcomes in common. You will marry a Christian, you will marry a non-Christian. Can't do both at the same time. So how do complementary and mutually exclusive events relate? Well, mutually exclusive events are complementary. They can't happen at the same time. And the last thing is that we can have independent events where one event does not affect the outcome of the other.